Overview. Concerned about AI hallucinations. While AI can be a valuable resource, it sometimes generates inaccurate, outdated, or overly general responses, a phenomenon known as hallucination. This lab teaches you how to implement a retrieval augmented generation (RAG) pipeline to address this issue. RAG improves large language models, LLMs, like Gemini by grounding their output in contextually relevant information from a specific dataset. Assume you are helping Coffee on Wheels, a pioneering mobile coffee vendor, analyze customer feedback on its services. Without access to the latest data, Gemini's responses might be inaccurate. To solve this problem, you decide to build a RAG pipeline that includes 3 steps. Generate embeddings, convert customer feedback text into vector embeddings, which are numerical representations of data that capture semantic meaning. Search vector space, create an index of these vectors, search for similar items, and retrieve them. Generate improved answers, augment Gemini with the retrieved information to produce more accurate and relevant responses. BigQuery allows seamless connection to remote generative AI models on Vertex AI. It also provides various functions for embeddings, vector search, and text generation directly through SQL queries or Python notebooks. What you'll learn. Create a source connection and grant IAM permissions. Generate embeddings and convert text data to vector embeddings. Search the vector space and retrieve similar items. Generate an improved answer by augmenting Gemini with the search results. Task 1. Create a source connection and grant IAM permissions. Create a source connection. To use remote generative AI models on Vertex AI in BigQuery, like Gemini and an embedding model, create a new external source connection. In the Google Cloud Console, on the navigation menu icon, click BigQuery. Navigate to Explorer, click +Add, and select Connections to External Data Sources. Note, alternatively, if you do not see the option for +Add followed by Connections to External Data Sources, you can click +Add Data, and then use the search bar for data sources to search for Vertex AI. Click on the result for Vertex AI. In the Connection Type drop-down, select Vertex AI Remote Models. In the Connection Type drop-down, select Vertex AI Remote Models, Remote Functions, and Big Lake, Cloud Resource. In the Connection ID field, enter Embedding Con. Click Create Connection. Once the connection is created, click on Go to Connection in the pop-up confirmation to navigate to the connection and copy the service account ID value. You need it later to assign permissions to this account. Grant IAM permissions. To use BigQuery data and Vertex AI resources, grant the service account the necessary IAM permissions. Next, you need to grant permissions via IAM. Perform the steps that follow. In the Google Cloud Console, on the navigation menu icon, navigate to IAM and Admin IAM. Click on Grant Access. In the Add Principals section, in the New Principals text field, paste the service account ID value that you copied earlier. Under Assign Role, select the following roles, search for them if you need to. BigQuery Data Owner. Vertex AI User. Click Save to apply the changes. Navigate to APIs and Services from the navigation menu icon, click +Enable APIs and Services, search Vertex AI API, click the Enable button. In Explorer, navigate to the three dots besides the project, click Create Dataset. For Dataset ID, enter Customer Review. Keep the other option by default, and click Create. Click Create Dataset. To connect to the embedding model, run the following SQL query in the query editor. Create or replace model customer review.embeddings. Remote with connection us.embedding con. Options, endpoint equals text embedding 005. To upload the dataset from a CSV file, run the following SQL query. Load data overwrite customer review.customer reviews. Customer review ID int64. Customer ID int64. Location ID int64. Optional, to check the uploaded data in the table, click Go to Table. Find the schema of the table and preview the data. To generate embeddings from recent customer feedback and store them in a table, run the following SQL query in the query editor. Optional, to examine the embedding results, click Go to Table. Find the schema of the table and preview the data. Note that the embedding results are floating point numbers and may not be immediately interpretable. Task 3. Search the vector space and retrieve the similar items. To create an index of the vector search space, run the following SQL query. Note, for datasets with fewer than 5,000 rows, as in this lab, creating an index is unnecessary. This step demonstrates the code required to create a vector space index when needed for larger datasets. To search the vector space and retrieve the similar items, run the following SQL query. Optional, to check the query results, click Go to Table. Find the schema of the table and preview the data. Task 4. Generate an improved answer. To connect to the Gemini model, run the following SQL query. To enhance Gemini's responses, provide it with relevant and recent data retrieved from the vector search by running the following query. Check the Gemini generated results in the query results section below the query editor. Questions for you. 1. How do you determine whether Gemini generates better answers with RAG than without it? Try testing it with code. 2. How can the code be improved? For example, instead of saving vector search results to a table, Task 3, could that process be embedded directly into answer generation? Task 4, for real-time retrieval? Explore these questions with any remaining lab time. Good luck.